How Intel makes their chips. A brief look into how chips for Intel Core processors are manufactured. It all starts with sand being put into a kiln and fired until it becomes a silicon ingot. The ingot is then sliced using wire saws into about 1 millimeter silicon discs. These discs are referred to as wafers. They are then polished, perfected, and ready to be sold to computer companies, in this case, to Intel. The wafers are then brought to clean labs for the companies they were sold to, where they will then undergo a process called photolithography. Photolithography is a process to imprint specific patterns on wafers. It applies a light-sensitive, etch-resistant material onto the surface called photoresist. Photoresist goes through hardening and is when exposed to UV light to make it soluble. The light shines through a stencil to print circuit patterns on each layer of the chip on the wafer. Once this process is over, the next process can begin, ion implantation, where ions are embedded in regions of the wafer not covered by photoresist. This dopes those regions with these alien atoms that can either be positively charged or negatively charged. This image depicts where the ion sources, the path that the ions travel to go into the wafer through the lens, where they will finally reach their destination. The next part of this process includes everything from etching to temporary gate formations to the final metal gate formations before the copper is put on. A fin is created for a tri-gate transistor using photolithography again. The unwanted silicon that remains is then etched away, leaving behind said fin. Even more photoresist is applied to portions of this transistor, and a thin SiO2 layer is created by inserting the wafer in a O2-filled tube furnace. This SiO2 layer can be seen as the little red part in the middle of the fin in the image to the left above. Using photolithography yet again, a temporary layer of polycrystalline silicon is formed. That is the yellow in the middle image. This becomes a temporary gate electrode. We need to insulate the transistor, so another step of oxidation is needed to create a silicon dioxide SiO2 layer over the entire wafer. This is in the third image where you can see it as a little red cloud around the whole transistor. The temporary gate electrode and gate dielectric are then etched away in the gate last procedure. High K dielectric material is applied to the surface using a method called atomic layer deposition. This high K dielectric material is the yellow in the center image. This material is also etched away in many areas, such as the silicon dioxide layer. In order to improve material performance and reduce leakage, a metal gate electrode, the blue line down the middle in the rightmost image, is formed over the wafer and removed from the regions other than the gate electrode. The next step in the manufacturing process has to deal with whatever metal one company chooses to connect their transistors to one another with. In this case, it's probably going to be copper. The wafers are put into a copper sulfate solution where copper ions will be deposited onto the transistor using a process called electroplating. Once the copper ions settle, a thin layer of copper will be on the transistor's surface, as shown in these images. Finally, the excess material, in this case copper, is polished off, revealing a very specific pattern of copper for the interconnections of the transistors. A neat thing that can be taken away from this presentation is that looking at the third image, the one all the way to the right, is that any chip can have up to over 30 layers of complex circuitry, even though they appear flat when you're just holding one. After the processing of each wafer is complete, each chip on every wafer is tested for its functionality. They are then cut into little pieces called die, and then they move on to the packaging. A die sorter is used for this job. In this case, we're looking at an IP520 die sorter, as it just takes each die off of the wafer and packages it up. The die, the substrate, and the heat spreader are then interconnected to complete a processor. A few processors out of every batch are thusly tested for functionality, performance, and power. Then each processor is binned and grouped depending on their capabilities, and then they are packaged up and shipped out to either retailers or system manufacturers, wherever they go, so that they can be sold.